When our data is not quantitative but qualitative, we need to consider other statistic tests. In this lecture, we are going to introduce chi-square statistic test, which can be used when we are evaluating whether the observed frequency distribution is significantly different from our expected frequency distribution. Let's say if you open a bottled water company and you are hiring a hydrogeologist to study the occurrence of the nature springs by rock type. And these are the recorded numbers of springs associated with each rock type. And we find out that there are 7 in the limestone, 3 springs in the calcareous marl, and 14 springs in the sandstone. And the areas of all these different rock types are the same. Now the question is the occurrence of natural springs influenced by rock type? Again, we are following the 5 basic steps of the hypothesis testing. The first step is state the null hypothesis and alternate hypothesis. For the null hypothesis, we are always stating that there is no difference. And here, since we are comparing the observed and expected frequencies, so we state that there is no difference between the observed and expected frequency. In other words, the springs are uniformly distributed between rock types. The alternate hypothesis is that there is a significant difference between the observed and expected frequencies. That means the springs are not uniformly distributed between rock types, or the occurrence of nature springs influenced by the rock type. And the second step is to select an appropriate statistical test. Here, the data is categorical, so we choose chi-square test. And the distribution is different than z-test or t-test. The chi-square statistic can be calculated using the observed minus the expected frequency, and then take a square, divide by the expected frequency, and then adding all the categories up, we get the chi-square statistic. And the observed is the actual value that's in the table previously, and the expected, since the null hypothesis is that there's no difference, so we expect that the frequency for each different rock type is the same. So this is our expected frequency for each of them is the same, and the total was 24, so 24 dividing by 3 is 8. Now, with this table, we can calculate the chi-square statistic. And observed minus expected frequency, take a square, divide by the expected frequency. For limestone, it's 0.13, and for calcareous marl, 3.13, and sandstone, 4.5. So the total is 7.75. So the chi-square equals to 7.75. And the next is to select a level of significance. We will use 0.05 again. And note the distribution of the chi-square test is different than the t-test or z-test. There's no values below 0, so it always begins at 0, and it is positively skewed. And the amount of the skewness decreases as the df, the degree of freedom, approaches 30. And when degree of freedom approaches 30, the chi-square distribution looks like a normal distribution. And the chi-square test will not give a direction of the relationship. It only tells you if the proportions are different from one another. So we can either reject or do not reject. So it will tell you they are different or they are not different. The fourth step is to look up critical values and compare to the test statistic. We have 3 different observations, so the degree of freedom is n minus 1 equals to 2. And the predetermined alpha is 0.05, so 5%. Then we look up this value. And now we have the looked up critical value. We need to compare it with our calculated chi-square. And recall, we calculated chi-square was 7.75, and the critical value is here 5.991. So our calculated chi-square is in this region. So we reject the null hypothesis. Therefore, we can conclude that with the 95% confidence, the observed frequency are significantly different from the expected frequency distribution. In other words, the springs are not uniformly distributed between the rock types. And we infer that rock types influences the occurrence of natural springs in Spring Valley. Calculating chi-square can be quite tedious, especially if you have more than 2 rows or 2 columns. And RStudio can calculate the chi-square of a table or of 2 variables easily. You can simply type in, you can give the value 7 to limestone, and 3 to calcareous marls, 14 to sandstone, and then bind these numbers together to form a data table. And then you can print out this data table, which is this. And use chi-square .test to calculate this table's chi-square statistic. And this is the result, which is the same as what we just calculated out. And what is different is a p-value is given out instead of a critical value. So with the p-value, you can compare with our alpha, which is 0.05. Here, p-value is 0.02, which is less than alpha. That we reject the null hypothesis, and the rock types can impact the occurrence of the spring. And in synchronous session this week, we are going to have a midterm review.